Hey everybody, Mr. Regan here, and today we're going to be looking at how we're analyzing our Team 8-2 data from our simulator to figure out whether or not this claim here is supported by the evidence that we have or refuted by the evidence that we have. And in order to do that, we have to look for patterns as to not only what evidence we collected, but what patterns do we see and why the data looks the way it does. And before we do that, let's do a quick overview. So if you remember in our simulator, you had these four dudes, blue 1, blue 4, yellow 7, and yellow 10. And we had to follow them and count the number of times they reproduced before they died in our ecosystem mission or our simulator mission. So remember, you had to click on that mission button at the top. You had to find reproduction mission, claims mission, and you had to, load up this very unique ecosystem. And if you notice that our ecosystem here had the same coloration as our yellow 7. So yellow 7 was our truly adaptive australope. It had the adaptive traits or the adaptive color that best suited the environment and allowed them to probably be the best to survive. Now, hopefully we loaded up the right mission. Otherwise, our data would be funky. So if you're somebody who checked that your data is good and you just realize that you loaded in the wrong mission, then you might need to redo your data both in the Amplify page and in the data sheet. So obviously you need to go back to task 1. If you know you loaded in the right mission, if you know that you recorded accurate data, meaning you accurately counted your australope and followed it correctly, and you know your data to be true, then that leads us to the next part, which is this claim. Australopes with adaptive traits are more likely to reproduce than australopes with non-adaptive traits. So the question is, does our data support this claim or does it refute it? Does it prove it to be true or does it prove it to be false? And we have to analyze our data for patterns. So we're looking for two kinds of patterns. First pattern is, do any of our numbers for all of our classes look similar? And do any of the reasons why these numbers look the same make sense? So let's first look at some patterns. So if you notice in our blue 1 column, all of our numbers are between 0.88 and 2 with an average of 1.3. For blue 4, all of our numbers are between 2.33 and 1.44 with an average of 1.78. For yellow 7, our averages are anywhere between 7.93 and 3.88 with an average of 4.77. And then our numbers here in yellow 10 are anywhere between 1.20 and 4.17 with an average of 2.81. And if you notice, as we begin to compare all of our data from all of our classes, we can identify not only where we have patterns, but also where we don't have patterns, maybe where things don't quite make sense. So let's take a look. In third period, we have our blues reproducing 2 or less times, with our yellows almost near 5, so over 4.5, and our yellow 10 at 2.58. Blues 1.476, 46 and 177, with our yellows at 7 and our other yellow at 1. Period 5, 1.19, 1.44, with our yellows at 3.13 and our yellows at 10. Period 6, 1.17, 2.3. We have 4.17, 3.17, and then period 9, we have 0.88, 1.88, 3.88, and 4.17. So first and foremost, we have to look for patterns. And when we are able to look for patterns, we're able to identify two things. Number one, what looks similar, and then we can figure out why. And then what doesn't look similar, we can figure out why. So every time we look at these data points, we see a few things. Number one, we see that the blues are typically pretty low in terms of their numbers, with our averages below 2. Okay, so they're reproducing less than 2 times in all of our simulators. Remember, each period represents anywhere between 20 to 30 students worth of data. So it's looking like almost everybody is averaging across all of their classes anywhere between 1 to 2 reproductions when they observe their australopes. When we look at the yellows, we have one that has a 7, but everybody else is between 3 and 4 typically. And then when we get to yellow 10, we notice that all of our numbers are between 1 and 4. Now, we have really low numbers for pretty much everybody here. and our averages are right around 1 to 2. Our numbers here are about twice as much as all of our blues. So it's looking like our yellow 7 is reproducing twice as much as pretty much anybody else. But then when we look at yellow 10, we start to see a little bit higher reproduction numbers. So everybody here's kind of following that same low reproduction pattern. This one is having a little higher or having some of the highest compared to these. But when we look at this, we have a few numbers that stand out. Number 1, for period 9, our highest number is yellow 10. But everybody else has their yellow 7 as their highest number, 4.7, 3.17, 3.13, 2.93. Notice, when we look at periods 3, 4, 5, and 6, yellow 7 has the most. Everybody else has less, with their yellow 10 usually their second most. So, why doesn't number 9 follow the same pattern, number 1? And number 2, does this help us understand which of these we need to pick? Well, let's start by looking at why ninth period doesn't quite make sense. So there's a few reasons. Number 1, we have human error. We as humans obviously sometimes make errors when we collect data, or if we loaded in the wrong mission, that could lead to us having incorrect data. So let's take a look. Period 9, what do you know? We have some errors here. So number 1, we have a few people who didn't fill in their final column. So we have 2 people who didn't fill it in. And when that happens, it affects your averages. So let's say that this one maybe was supposed to be a 1. Now all of a sudden your average drops. Maybe this one was supposed to be a 2. Now all of a sudden your average drops, and notice our numbers are starting to look normal, where we have really lows in the blues. Our highest is yellow 7, and usually our yellow 10 is a little higher, but not the highest. But because we have these errors, we unfortunately have data that is a little bit skewed. We also notice that across the board, like let's take this one for example, this individual one follows the pattern 0040, with this one being the highest and all the others being the lowest, and so on. We have a few that obviously don't follow the pattern, but remember, our simulator shows a random occurrence of some surviving and some not. In this case, yellow 10 maybe got lucky. Maybe their predators didn't find them. Maybe he was in a spot of the ecosystem where there weren't a lot of predators. There's a lot of reasons this could have happened, okay? But when we look at data as a whole, we're able to identify these patterns and begin to make sense. So the question then becomes, which one of these do we pick? Does our data support the claim that australopes with adaptive traits are more likely to reproduce than those with non-adaptive traits, or does this refute? Well, we have low blues, high 7s, and we have medium yellow 10s. We have some errors here, obviously in period 9. The question is, does that data support that our adaptive australope reproduces more, or does it prove it and refute it? Your call. Either way, at this point, you should be able to complete your survey and then move on to the next task where you answer those questions. If you have questions or need help, reach out to me. If you put your X in the yellow or the red section, obviously check in. Otherwise, good luck.